Welcome to Building Games with Scratch 2.0. Scratch is a free, browser-based, multimedia programming environment. It's easy to learn, so whether you just want to make fun games or you are an educator looking for a way to engage kids, Scratch is serious fun. And we're going to start with a simple animation. In the next couple videos, we'll make a Scratch project that responds to input from the user. And we'll see how easy and useful it is to share our efforts with a very active online community. Follow along with me and you'll be amazed by what you can create and share by the end of the series. In upcoming sections, we'll make an arcade-style Breakout game, a collect and avoid game, an escape the room point-and-click adventure, a tower defense game, and a maze game. But you probably want to get started, right? Okay, I do too. Scratch runs completely in any web browser that runs Flash. There's nothing to install. You start by going to scratchmit.edu. I'll take you to a project that I've already started, just so you can take a look and see what a Scratch project is like. This cat is what we call a sprite. It represents a character that we can bring to life by adding instructions over here in the scripts area. Costume comes with some content, and sounds also comes with some content. And we can add more. We assemble scripts by using these individual commands that Scratch calls blocks. Each of these blocks represent an instruction for Scratch to follow. If we click on a block, we see what it does. This block says move 10 steps. This one says turn right 15 degrees, and now I'm going to turn left 15 degrees. In later videos, we'll learn more about what some of these other collections of blocks do. But for now, let's start new project. I'm going to sign out, and I'll show you what it looks like when you first go to scratch.mit.edu. And you can start creating right away without even creating an account. If you want to save it, however, you'll have to create an account. Now, as a new Scratch member, you'll see this tutorial pop up over here. You can follow that tutorial on your own. I'm going to close this tutorial and move on. With the default sprite, this cat, on the stage, which is this area right here, we can make the cat do things by dragging these blocks of code, such as, I could move 10 steps, over to this assembly area. Now, we'll explore all these palettes later on. For now, I'm just going to click here on Looks. And I'm going to pick a block which says Next Costume. Well, if I don't know what that means, I can just click on it. And we say, aha, remember I showed you that cat has two different costumes? Now, I can drag and drop that block, and it kind of snaps there like that. Now let's add a sound. Now from the sounds, I could play this meow that comes with Scratch, but I want to make a footstep sound. So I'm going to pick this play drum sound, which if you just click on it, okay, that's the noise that it makes. So now I've built a stack. When I click this stack, see what happens? We move 10 steps, we change the costume, and you play this drum sound. All those work in sequence to create a walking animation. Okay, that's cool, but what if we want to make that sprite keep walking? Well, over here in the control palette, here's this block that says repeat 10. That block is shaped so that you can put stuff inside it, and this stuff inside it will happen 10 times. So I'm going to put this, and whoop, this happens all the time in Scratch. I've dropped a block on top of some other blocks. I want to put these blocks inside here. I don't want them to be underneath here. That happens all the time, and it's really kind of easy to fix. Just drag the bottom of the stack, and I can insert it inside there. And now if I want to get this move so that it's inside the repeat 10 loop, I have to break the loop off from the bottom, and then I drag this block and slip it in there in the top. So now, when I click this, my cat moves 10 times. Not bad for a first try. Scratch is wonderful because you can edit all these values very easily in order to change the way your program works. Now, a little while ago, I spent about 5 minutes playing with all these settings, and I found a better sound effect, which was played drum. I'm going to take the sound 10, which is a wood block, and I'm going to make that 0.1 beats. I want my character to take bigger steps, so I'm going to change it from a 10 steps to 20 steps, so he's going to move more quickly. And also, I want to make it so that the cat goes back to the center rather than eventually walk off the screen. So I'm going to go here to motion, and I will take go to, we'll put him at 0, 0, which is the center of the screen. And I'm going to go over here and grab this when green flag clicked. One of the traditional ways to start a Scratch program is by clicking here on this green flag. So let's do that. Now, I went through all that very quickly. In later videos, we'll go through the creation process much more carefully and more deliberately. But right now, my point was just to demonstrate how easy it is to tweak your code in Scratch, and you should feel free to experiment on your own. So we've learned about MIT's great educational programming tool, Scratch, and in just a few minutes, we've learned how to animate a character. In the next video, we'll learn how to control a character with the keyboard. It's easier than you think. Animate a character and save your work in Scratch 2.0. In this video, we'll move a character with the keyboard, and then I'll show you how to save your work. All this will take just a few minutes. Point your browser to scratch.mit.edu. Join Scratch if you haven't done so already. I'm going to log in, and I'm going to create a new project. I'm going to call my project Hello World. Now here in the Looks tab, here's a block that says Say Hello for 2 secs. Well, that makes sense. I'm going to change it so that it says Hello World. And I'm going to drag this block here in the Script Assembly area. Now in the Events palette, we see blocks that start actions in various ways. Typically, the way you activate a Scratch program is by clicking on this green flag. So I'm going to take this when green flag clicked, and I'm going to drop it at the top of my stack. Now when we click the green flag, our character says Hello World. Let's add some keyboard controls. Under Events, we're going to drag this block that listens for keyboard input. The default is space, but I'm going to pick right arrow. So what this means is when the right arrow key is pressed, I want to make my cat move 10 steps. I'm going to right-click and duplicate this stack. And I'm going to change this right arrow to left arrow. If we move 10 steps, if we go 10, it moves us to the right. I'm going to select in here, and I'm going to type a -10, and I can click here on the green flag. The cat says, Hello, World. And now when I click the right arrow, the cat moves to the right, and I click the left arrow, the cat moves to the left. Look at this delay. I click, and there's a little pause before the cat starts moving. I click, and there's a little pause before the cat starts moving. Do you notice that delay? These separate when key pressed scripts, when the right arrow key is pressed and when the left arrow key is pressed, they're very easy to drag out of the events area and drop into this script assembly area. If I tap, 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 I don't have that delay. But really, who wants to play a game with that kind of a delay? I'm going to show you a different way that will end up with the same right and left motion, but it will be smoother. I'm going to remove this when right arrow pressed block. I'm going to delete that. I'm going to go to the control group, and here I'm going to take this if-then block, and I'm going to put it here in this stack. If some condition is true, then I want the computer to do something. And what I want it to do is to move my cat 10 steps. We need to come up with something that goes in this box, some condition that Scratch can check, such that if it's true, the cat will move forward 10 steps. Well, what's the question that we're asking? What are we looking for? In this sensing palette, I'm going to take this key space pressed block, but I don't want the space key. I want to pick the right arrow. So now what this says is, when the green flag is clicked, we're going to say Hello World for 2 seconds, and then we're going to check and see if the right arrow key is being pressed. If it is, then we're going to move 10 steps. So let's run this program, and let's see what happens. Wait a minute. I'm clicking the right arrow key and it doesn't seem to work. I click the left arrow key, it seems to work, but the right arrow key doesn't work. We would expect that if the right arrow key is pressed, the cat should move forward 10 steps. Actually, this script is doing exactly what we told it to do. This say message, hello world, appears just once, and then just once the program checks whether the right arrow key is pressed. So right now I'm holding down the right arrow key, and I'm going to click the green flag. And there's a delay because hello world happens for 2 seconds, and then the cat jumps forward. I'm going to do that again. 2-second delay, the cat jumps forward. Well, that's silly. We don't want Scratch to check the right arrow key just once. We want it to check it over and over again. What we need to do is find a way to tell Scratch to run these instructions over and over and over again. And to do that, we go to the Control palette and we take this forever block. The forever block is your friend. Many, many times, if you're running into a problem with your code, it may very well be because you forgot the forever block. So when the green flag is clicked, we want hello world to happen once, but we want this to happen over and over again. I'm going to drag this if-then block. I'm going to tuck it inside the forever block. And now, when the green flag is clicked, hello world will happen for 2 seconds, and then this should happen over and over again. That is, Scratch will check to see whether the right arrow key is pressed over and over again. So let's see if that works. Hello world happens, and I'm just holding the left key down. See how jerky that motion is? I'm going to hold the right key down. Nice and smooth. Okay? So, this block of code that moves the cat to the right was harder to write. It's more complex. But that motion is so much smoother, it's really worth it. So now what I need to do is duplicate this functionality for the left arrow key as well. First, I'm going to drag this if block out for a little bit. I'm going to right click, I'm going to get the duplicate block. Stick that down right underneath here. I'm going to change the right arrow so that it says left arrow, and then I'm going to put all this back inside the forever block. And we'll arrange things so that that's out of the way. Actually, you know what? We don't need that anymore because we've duplicated that up there. Aha! Changes to -10 steps. And now I click the green flag, we get hello world, and now we have nice smooth motion right and left. Actually can delete that. Nice smooth motion. It was a little more work, but it's much better performance, and that's a good trade-off. But there's always something though. I mean, does it bother you that the cat is walking backwards? Okay, well, we can do better. Here in the motion palette, we see a block that is point in direction. So, point in direction, 90 is right. So, we'll put here, just underneath the top of the if-then statement, this point in direction 90 degrees and move 10 steps. I'll get another point in direction, I'll stick it here in left, and we'll face the cat left. So, what do we think is going to happen? When the right arrow key is pressed, the cat's going to face right and move 10 steps forward. When the left arrow key is pressed, the cat's going to move left and will move 10 steps backwards. Let's see what happens. That works, and whoa! I have to drag this guy back on here. So the right arrow key works. For the left arrow key, the cat turns upside down and he's still moving right. Well, we can fix that. First, I'm getting tired of dragging my cat back to the center of the screen over and over again. So I'm going to take this go-to block. I'm going to set the go-to block, the X and the Y values will be equal to 0. And I'm going to move this go-to block here so that now wherever the cat ends up, when the green flag is clicked, the cat will end up back in the center, though right now my poor cat is upside down. Well, what do we do about this unexpected, weird behavior? Let's look at it more closely. When we click this eye here on the cat sprite icon, we see something called rotation style. The problem here is when the cat is facing this way, because the rotation style is a 360-degree rotation, the cat is just spinning upside down. This option right here, this right-to-left mirroring rotation, watch what happens when I drag. Now the cat is facing to the left. The cat, nothing is happening with the cat. Aha! When it breaks that sort of vertical plane, the cat flips back and forth left and right. So we're going to change the rotation of the cat and make sure the cat is at 90. You don't actually have to adjust that at all. All you need to do is click this left-right rotation style. And now when we run it, the cat he's moonwalking, he's going backwards there. Why is he going backwards? Well, Scratch is doing exactly what we told it to do. We told Scratch to move -10 steps when the left arrow key is pressed. So now that the cat is facing in the direction -90, if we want the cat to move in the forward direction, the forward is now this way. So we're going to change this to 10 steps. And now, when we run it again, we have a cat who moves to the right and a cat who moves to the left, nice and smoothly. Now, did you notice that when you run the game, I'm holding a key down, nothing's happening. Oh, wait, don't try that again. Run it. I'm holding the left key down, nothing's happening, and now he turns left. Well, that's because we told Scratch to wait for 2 seconds while Hello World is being displayed. And now that we've been running the program over and over again and making a little change and running it again, those 2 seconds are starting to add up. So what we can do, however, is we can split these scripts up in 2 different ways. I'm going to drag this forever block away. I'm going to get another when green flag clicked. And now we've split up the behavior of the scripts inside the cat's sprite. So that now when the green flag is clicked, this is a short list of things that will happen only once. But this loop will begin immediately. So when we run it now, for a couple seconds while that Hello World speech bubble is happening, these instructions are running right away. We no longer have that 2-second delay. Well, that was a tiny bit of extra effort in the short run, but the game is much more responsive now. Well, it's not much of a game at this moment. It's a simple animation. We'll keep working on this project in the next video, where we'll give our cat something to do. To save what you've done so far, make sure you've joined Scratch, and you can get a free account and save it that way. It's really so simple, I don't really need to walk you through it. If you don't want an account, from File, you can download this project to your own computer and save it someplace, and you can then later upload. But really, it's really a lot easier just to get yourself an account and save your work that way. So we've done a simple animation. I've reminded you to save your work. And then in the next video, we'll create some things for our cat character to collect and avoid. So far, we've worked with just one sprite, but now let's add a second sprite for our first one to interact with. We can import a sprite from the Scratch library, we can draw one ourselves, we can upload one from our hard drive, or we can use a webcam to take a picture. We're going to import a sprite from the Scratch library. I'm going to click on Things, and I'm going to pick this apple. I'll place it right here. This cat is just called Sprite 1. I want to give that cat a better name. I'm going to call this the player. And I'll click this to go back. Okay, so the new sprite that we created is already called Apple. Let's make something happen when the player bumps into the apple. And since the thing is going to happen to the apple, we're going to make the apple disappear. We want to add the scripts to the apple. So let's pick an event, when green flag clicked. If something happens, then the thing we want to make it happen is we will go to looks and we will hide the apple. And the sensing area, we're going to put touching player. If you paid attention in the last video, you might have noticed that I'm missing something here. I need to put all that stuff in a forever block so that over and over again, as long as the program is running, it'll continuously check to see whether the apple is touching the player. So let's see if that works. Yay! The apple disappears. Let's add a sound so that when the apple disappears, we get a little noise. From the Sounds tab, we see that this sound already comes with the sprite. So we'll go back to the Scripts tab. From the Sounds palette, I'm just going to add this Play Sound Pop. And now the apple should pop when it disappears. Let's see if it does. Oh, wait a minute. That apple's gone. Now remember, when we had the cat touch the apple, we made the apple hide. We have to tell Scratch to make the apple visible when the game begins. So let's take the looks, and we will always show the apple when the game begins. Okay, that's improved. Okay, that looks good. And wait a minute, what happened? Will it work that time? I touch the apple, it disappears. Now, did you hear that pop noise? What that means is, very quickly, even though we've told the game, when you start, move the cat from wherever it is to the center of the screen, the program is still sensing that the player is touching the apple in the fraction of a second before this script runs and moves the cat out of the way. See what's happening? Now, if I move the cat away and I restart the game, we don't have that problem. So what we need to do is add a slight delay before the game starts checking to see whether the apple is touching the player. So under Control, we'll take this wait 1 second block, and now let's try it. That should be fine. Okay, we run it again, no problem. Okay. Well, what's a game without threats? Let's add another sprite. If this is a game about eating things, well, an apple is good for you, so let's take something that's not so good for you. Let's take this lovely donut. I'm going to place this donut over here. And what we want to do is reproduce this code from the apple and the donut, because most of the core functionality is the same. Now, we could just recreate this block by block as we did in the apple here inside the donut. But instead, I'm just going to, with the apple selected, I'm going to drag this stack of scripts. I'm going to drop them in the donut. And now the donut has a copy of all that stuff. So when we run it now, the donut disappears, the apple disappears, and they both reset. So far, so good. Let's give the player some feedback to help the player learn that the apple is a treat and the donut is a hazard. Well, we can start just by keeping score. With the player selected, let's go to this data palette. We're going to make a variable, and we'll call it score. We can just leave these defaults. Since score is going to change over the course of the game, let's make sure that we start the game and we set the score to 0. And then when the apple bumps into the player, we will then change the score by 1. Yay! Okay? Good. Now, it would be a simple thing to come over here to the donut. We could say, well, touching the donut changes your score by -1. Then you can get a negative score, 0 score. Okay, so you could do that. But I want to do something different. I want the donut instead to affect our health. So I'm going to throw that away, reassemble my blocks. Health is connected to the player. I'm going to go back to the player icon. I'm going to make a variable. We'll call it health. We'll leave these defaults. And we'll also set the health to 0. It's kind of an unrealistic number, but I want to show you very quickly how to react to the health going to less than 0. We'll just quickly go to a control palette. We'll take another if-then block. Something new is operators. We get all these mathematical symbols here. Let's take this less than block. And the things we're going to compare is we're going to say, take this health. So if the player's health is less than 0, then we will go to control and we will stop all, which is how we end the game. Let's see if that works. Uh-oh, well, silly us, we forgot to go over to the donut and actually tell Scratch that when a donut is touching the player, we need to change health by -1. Now, when we run it, score goes up, health goes to -1, and the green flag is no longer running, and the keys don't work. You would probably want to give your player more feedback than that, and in fact, in Section 3, we'll do a more fully implemented catch and avoid game. I'm just trying to very quickly blow through some programming concepts so you have an idea of what's going on here. And now we can see how we can kill the player in one move. That's a little bit harsh. Let's, instead of killing the player right away, let's give the player a bit more health. And instead of killing the player outright, let's give some negative feedback in the form of a sound effect. So we'll go over to the donut. Instead of playing the sound pop, which right now is our only option, I'm going to add another sound to this donut. I'm going to import from the library a human sound. I'm going to pick this male cough sound. And now, when I go back to scripts, this option right here has the cough male sound. So we'll give it a different sound effect. So that sound effect is a little bit of feedback, but let's give another kind of feedback. Let's give it a little kinetic feedback. I'm going to make the cat freeze. I'm going to make him freeze for about half a second. And let's see how that feels. Okay, so, oh, well, wait a minute. The cat's not freezing. I told Scratch to wait for a half second, but the cat's not freezing. Well, the reason is because this forever block is not handling the motion of the cat. So although this forever block is waiting for half a second, over here, this is the forever loop that's checking to see whether the cat is moving. What I can do is, well, first I can remove this, reassemble that, delete that. Over here in the cat, we're kind of going to have to do the same thing in reverse. Whereas over here, we check to see whether the donut was touching the player. Here, we're going to check and see whether the player is touching the donut, because this behavior is going to affect the player. We're going to wait 0.5 seconds. Now, there we go. You see the player kind of stutters there. So that was just a simple little lesson to remind you that if you are trying to code something that's going to affect an object, make sure that you're putting the code in the scripts area that actually is connected to that object. When the donut and the player interact, something happens to the player and something happens to the donut. The stuff that happens to the donut, most important one being that it hides, happens here in the donut, but when the player recoils or gets stuck, we have to code that over here in the player object. So we've got the makings of a little game here. Section 3 will flesh out the idea of a catch and avoid game with an infinite supply of falling objects to catch and avoid, and we'll see how that develops. For the last video in this section, I will show you how to share your game, and that's coming up next. In this very short video, we're going to go through how to publish your work on the Scratch website. If you haven't yet gotten a Scratch account and signed in, you'll see a button here that says Sign In to Save. When you click that, you'll be prompted to sign in. I've already filled in my username and password. You should join the Scratch initially if this is your first time, but I'll sign in. Here we go. It's saving. And now you'll see this Share button. Sharing a project on the Scratch website is how you publish it. Scratch does its magic, and now I'm presented with a project page that I can customize and a URL that I can share. Other Scratch users can give feedback. And you can also embed this game on your own website or blog. People can tell you what they like about your game and also give you suggestions for expanding it. Tutorial section 7 will go over polishing a game and publishing it online in the Scratch community in more detail. But if you followed along this far, congratulations! You are already creating and sharing with Scratch. In Section 2, we'll create a ball and paddle game, our own version of Breakout. Section 2 of Building Games with Scratch 2.0. Breakout, let's create a simple ball and paddle game. In Section 2, we'll create a bouncing ball. Later, we'll add ball death and paddle bounce. We'll add a brick that vanishes when we hit it. We'll create a whole wall of bricks with cloning, which is new to Scratch 2.0, and we'll add a win game state. If you were going to try to do something like this in a traditional programming language, you'd have to do a lot more work up front. I will touch on some important computer science concepts like objects, iteration, and messaging, but I'll try not to let that get in the way of making a fun little quick and dirty game. We'll start by signing in, and we'll create a new project. Scratch shows us this default project. We don't need the cat character for this project. Instead, I'm going to import a thing. We'll use this basketball. This ball is really too big for this screen, so what we're going to do is we're going to make it so that when the program starts by the green flag being clicked, go to Looks, and we will set the size of this object to 25%. And now, yeah, that's a little bit better. Now let's make the ball move. When the green flag is clicked, we want it to move forward 10 steps. Right now, when I click the green flag, Scratch moves the ball forward 10 steps and then stops. We want the ball to keep moving forward. So we will go to Control and put this move statement inside a forever block. Scratch won't actually move the object off the screen. It'll stick there on the edge. But we want the ball to bounce. Well, fortunately, there's a block for that. Motion, if on edge, bounce. So let's try it. Aha! Okay, well, that's kind of boring. Let's add a little randomness. Under Motion, we'll go to Point in Direction, and we'll go to Operators, and we'll pick random number from -45 to 45. And what that will do is it means every time the game starts, -45 to 45 would be an arc that's moving upward. Okay? It's time now that we create the paddle that we'll use to bounce the ball and actually play the game. I'm going to click here on Paint New Sprite. That opens up some editing tools. Click this rectangle tool. And see this very faint crosshair? That represents the center of your image. I'm going to draw a flat rectangle a little bit below that crosshair. Over here in the window that Scratch calls the stage, I'm going to drag this paddle down here. With my new paddle sprite selected, I'm going to click on the Scripts tab, and now I'm going to assemble these blocks. From Events, I'm going to get When Green Flag Clicked. From Control, I will get a Forever block. From Motion, I'm going to get Set X to. I will set the X coordinate of this paddle equal to, let's go to Sensing, and I'm going to get the mouse X coordinate. That will track the horizontal position of the paddle to the position of the mouse. Now, I've been referring to this sprite as the paddle, but when I created it, Scratch gave it a generic name. I'm going to click on this I button, which will allow me to rename this, and I will call it paddle. And then I click the triangle. Now this sprite is called paddle. Let's run it and see. Yep, there we go. Okay, so the paddle is tracking the X position of my mouse, but of course I haven't written any code to make the ball bounce off the paddle yet. Now, while you never have much control over the ball in a Breakout game, we can at least let the player launch the ball when ready. We're going to add some simple code that will make the ball follow the paddle until the user presses the space bar. So we need to go to the ball, and we're going to add some code that says, from the Control tab, repeat until. The condition we're going to check for is the space bar being pressed. And the thing that we're going to repeat is making the ball go to, not the mouse pointer, but the paddle. And we're going to drop this code right in here. And now let's run it and see what happens. Okay. So the ball is kind of stuck there on the paddle, and I hit the space bar, and we fire the ball off. Okay, now again, I haven't written anything to make the ball bounce off the paddle, but we'll get to that in a minute. We've created a paddle that we can control with the mouse, and we can launch the ball from the paddle. What's next? Well, in our next video, we'll make the ball bounce off the paddle, and we'll make the game end if the player misses the ball. In a paddle-based arcade game, we expect certain things. Now, the ball should bounce off the paddle, and also missing the ball should make something bad happen. So let's start to make our project behave more like a game. First, let's get some bouncing action here. I'll go to Control, and let's get this if-then block. If something happens, then we do this. The thing we're going to check to see that happens, we're going to sense to see whether the ball is touching the paddle. And if the ball is touching the paddle, we're going to change the direction of the ball, change the motion. We're going to point in a certain direction. Now, Scratch indicates direction this way. Up is 0. To the right is 90. To the left is -90. And down the bottom is either 180 or -180. It's a circle. There are 360 degrees in a circle. So if we want to point in the opposite direction of the direction we're already pointing, we want to add or subtract 180 degrees to our current direction. So we're going to use this operator that is the minus operator, and we'll fill those holes in such a way that we take 180 degrees minus our current direction. And we'll put this block here inside this forever block. It works, but my ball kind of gets stuck to the paddle, like that. We can fix that pretty easily, though. Let's go to the paddle sprite. We'll go to the costumes, and see this gray crosshair right here? That's the center point of the costume. When the ball tracks the paddle, the ball is attracted to this center point. We need to make sure the center point is high enough that the ball won't actually touch the paddle while it's tracking the paddle. So let's click this Set Costume Center icon. I'm going to move this a little bit higher up. Yeah, that's good enough. And then let me run it again. And I'm not sure why this works, but sometimes you kind of have to drag the ball a little bit off the paddle. You see the ball is hovering a little bit too high. Well, maybe that's too high, but at any rate, we no longer have the problem of that ball being stuck to the paddle, and it bounces off the paddle just fine. Well, let's figure out how to end the game when the player misses the ball. It's code that should be attached to the ball, so let's make sure the ball is selected. We'll go to Scripts, and I'm running the mouse along the stage. You see these numbers down here in this corner that are changing? This shows me that it's tracking the X and Y position of the mouse pointer. And down here, the bottom edge of the stage, the Y coordinate is minus 180. So what we're going to do is we're going to check and see, okay, and the Y coordinate of this paddle is about minus 150 or so. So what we need to do is check with some code whether the Y coordinate of the ball is less than, a lot less than, the Y coordinate of this paddle, and we'll know that the paddle has missed the ball. So let's add these blocks to the script of the ball. From control, we get an if-then block. From operators, we're going to need a less than block. From motion, we need the Y position. And the thing that we want to happen, we go to control, we're going to stop all. We want to check to see if the Y position is less than, well, down here is 180. Let's try Y position of minus 160. So if the ball passes this minus 160 position, then we'll say the game's ended. And we want to place this inside this forever loop, like that. So let's run it and see if the game ends. And the game ends when the ball passes the paddle, so that's what we wanted. It works, but let's add a little bit of feedback. Just before we end the game, here in the Scripts tab for the ball, we're going to add a, from the looks, let's take this say block, and we'll say game over. And so now, when we miss the ball, we get a message that says the game's over. Well, what's an arcade game without some sound effects? Let's at least get a little bit of sound here. Over in the Sounds tab, let's choose a sound from the library. We'll pick Effect, and we'll just get a simple pop. This is going to be the bouncing sound effect. Now that I've loaded that sound from the library, when I go to Scripts, I can now go to the Sound palette, and I can play this sound pop when the bounce happens. Now we can bounce the ball off the paddle, and if you listen, yay, we have a little sound effect. Oh, and we also have game death. The point of this game is to break through a wall of bricks by bouncing the ball off of the bricks. So for our next video, we'll add a brick. So we can bounce a ball on an empty screen, which is fun for only so long. So in this section, we will create a brick that will vanish when the ball hits it. We'll create a new sprite by clicking here on the Paint New Sprite icon. I'll select the Rectangle tool. I want a filled rectangle, and I'm going to pick a nice reddish bricky kind of color. And near this crosshair, which is the center of the costume of the object, I'm going to create a wide rectangle. Click here, and that makes it appear. So I'm going to use good programming techniques. I'm going to give this object a meaningful name, call it a brick, and I'll place it, just place it there. Next, we'll assemble the stack of blocks that will make the brick disappear when it touches the ball. So we'll go to Scripts, and what we need is From events, we need when the green flag is clicked. From control, we'll get a forever block. We'll also get an if-then block and slip that inside the forever block. The condition we're going to check for is sensing whether the brick is touching the basketball. And if it is, then from looks, we will click on hide. Now when we run the game, the brick should disappear when the ball hits it. There we go. Took a while, but it works. Okay, now when we run the game again, no brick. Why is that? It's because we haven't told Scratch that when the game begins, we need to show the brick. So we'll run this again. We have a brick, and now we'll hit it. It's gone. We start it over again, and the brick is back. Wonderful. Let's add a way to keep score. We'll just increase the score each time the ball hits a brick. Since the paddle is the player's avatar, we use the paddle as a place where we keep track of the variable from the data palette. We'll make the variable score. And what we want to do is when the game begins, we'll set the score to 0. And then in the brick, when the brick disappears, we will change the score by 1. Now currently, the ball just keeps sailing right through the brick after it hits it. And you see the score went up by 1 when we restart. Score is 0. That's great. But we want to change that behavior so that the ball will bounce off the brick. I could add code to the ball, checking to see whether the ball has collided with the brick. But we already have this code in the brick that's checking to see whether the brick is touching the basketball. Before the brick disappears, I wanted to send a message to the ball telling the ball to bounce. Messaging is something new that I'm introducing to you. The way we send a message from one object to another in Scratch is using the events block broadcast message. Most of the time, when we give commands to a sprite, it's kind of like your brain giving orders to your own body. Only you know what you're thinking. But if instead of thinking, you shout something out loud, everyone in the room will hear what you say. But it's up to each individual to decide what to do when they hear what you say. So in a similar way, we're going to use the broadcast block to send a specific message out to every object in the game. And we'll write a script that makes one specific sprite listen for one specific message and then react to it. So with the brick selected, I'm going to add the broadcast block. Now the message we send could be anything at all, but I'm going to make it a meaningful message. The message is going to be ball bounce. That's my message. Now we'll go to the ball, and I'm going to add this when I receive ball bounce block. And what we're going to do is we're going to, let's add a little sound effect. We'll place the sound pop, and then we will reconstruct the block that is point in direction 180 minus direction. I can do it this way. I can go 180 minus motion direction. Another thing that I could have done, just drag this off and delete that. I can just duplicate this block, grab it over here, because that's exactly the block that I want to use again. So let's test it. So now we have a brick that will disappear when it's hit with the ball. It will also send a message to the ball, making the ball bounce. Yay! Okay. Now, in the next video, we will fill the playing field with more bricks. My next step is to create a wall of bricks with the cloning feature of Scratch 2.0. In order to make more bricks, I could copy each one like this. I right-click, duplicate. Right-click, duplicate. I could do that over and over again. But let's say that now I decide, after I've made a couple bricks, I want to change the costume of the brick. What if I don't like that color? I want to make the brick a little bit lighter. I can fill with a little bit lighter color. Well, I would have to make this change to each individual brick, and that would be very tedious. With 3, it's not so bad, but if I had 50 different bricks, it would be tedious to make those kinds of changes over and over again on each individual brick. So I'm going to delete these extra bricks that I created just for this purpose. And I'm going to show you a better way to make multiple copies of an object. We'll use the cloning block, and we'll also lay out those clones automatically using the repeat block. So I'm going to start by placing my original brick up here in the top left corner, where I want it to be. Now in my Scripts tab from the brick, I'm going to take these blocks and I'm going to pull them off of the when green flag clicked block. The reason is because when we clone a source object, we set up that original object differently than when we set up the individual clone. So we're going to save this stack for the individual clones to use. We have a different setup that we need to do when the game begins. We're going to create a row of bricks. We're going to do that by moving our original brick and kind of leaving copies in its wake. So here's what we'll do. From Motion, we'll click Go to this current location. These numbers match where the brick is right now. From Control, I'm going to get the repeat block, and let's say that looks like maybe that would be 6 bricks across. We can adjust it later if I'm wrong. And then under Control, I'm going to create a clone of myself, and I'm going to move, let's see, estimate. X is about 230 there. It's about 173 there. So maybe that's 60 pixels across. I'm just going to guess. I'm going to change the X by about 60. Let's see how this works. Okay, that's actually pretty good. I'm going to change it so that there's a little bit extra space in between those bricks. So I'm going to make this change by 63. I'll run it again. Okay, that was pretty fortunate for me. If instead I'd misestimated and I said maybe try 70, you can see that's way too many. If I'd said 50 instead, which is way too few, you can see you get one long. Those are actually individual separate bricks. 64 was about right. Yeah, that's pretty good. We now have a row of bricks. And if I run this game... Uh-oh, wait a minute. This ball isn't making the bricks disappear. Well, the reason for that is, remember, I took this stack of blocks, which is what hides the brick when it senses touching the ball. I pulled it off of this when green flag clicks, so it's not running. What I need to do instead is under Control, when I start as a clone, here's what I want it to do. Run this, and now each individual brick is running its own separate copy of this script. So, when the ball hits these bricks, aha! Oh, well, so much for my aha. Let's try it again. There we go. And notice my score is going up, each individual brick is disappearing, and doesn't that look nice? Now, why is there an extra brick sitting there that's not interacting with the ball? I stop it. This brick right here, that is my original brick. Remember, we started the brick over here. When the green flag is clicked, we go to this location, and then 6 times, we create a clone of that original brick. It kind of leaves a copy in its wake. And then this brick moves over here, leaves a copy. This brick moves here, leaves a copy, etc. The original brick is now sitting here. That's the original brick. That's not really doing anything. So what we need to do, I guess, would be to hide that brick when we're done with this process here. So let's do that. Let's start this by showing that original brick, and we'll end by hiding that original brick. There. And now did you see it flashed and kind of disappeared? Let's make that 7 repeats. And now we have an extra brick that appeared here. See? Do I need to spend all this time convincing you? Well, there we go. I spent the time. Okay. So now we have a row of bricks, all of which work, and we can clear them. To fill the whole screen with rows just like this, what we need to do is take this block of code, the repeat loop, and surround it with another repeat loop. This will be our number of rows let's say 5 rows. I'm going to put this stuff inside there, leave the height at the end, and now after we finish a row of 7 bricks, then we need to go to motion. Let's change Y, the Y direction by, that is 140, and that is 119. So let's say 32. Let's see how that works. Whoops. I should change it by minus 32. And I also need to, what else do I need to do? I also need to, instead of just changing the Y location, I also need to change the X location. The X location was minus 203. So let's set X to minus 203, which is the original location I got from that coordinate, and let's run it again. There we go. That's more like what I'm thinking of. Although I think that 32 is too large, I'm going to change that to... I've sped up this section. I spent about 2 minutes tweaking the numbers. Programming often involves a lot of trial and error. You make a little change, you run the program, you see whether you like it. Depending on the shape of your original brick, you may have a larger or smaller number of bricks that fit on your screen. There, now that brick wall seems to be centered. We've learned how to clone a sprite. We've used nested repeat blocks to lay out a nice grid. And now if we change anything in the code about this brick, let's, for instance, change the costume to, let's make it a brownish kind of color. And now when we run it, we have all brown bricks. So you see how useful it is to create clones of objects, because every change you make to the original gets duplicated automatically in all the clones. In our final video of the section, we'll polish up the game by adding a way to win. In this video, we'll end our Breakout project by adding a way to win the game. We'll keep track of how many bricks have been destroyed, and then we'll create a sprite with a message that tells the player he or she has won once all the bricks are gone. We'll start by painting a new sprite with the "You Won" message. Scratch does have a text tool. You can play with that if you'd like. But to save time, I'm just going to paint a simple message. I'm going to get a little bit thicker line, and I'm just going to write, "You win." Call that win message. In the Scripts tab for the "You Win" sign, we'll add the code that checks the score. We'll start with the flag block. We will begin by hiding this message. From control, we'll get a forever loop. We'll also get an if-then statement. From operators, I will get the equals block. From data, I will get the score. And I have 35 bricks. So we know that if the score is 35, then I've removed all the bricks on this screen. And if that is the case, then I want to go to looks. I want to show the "You Win" message, and then from control, I will stop all scripts. All right, well, using Scratch, we've gone pretty quickly from 0 to a playable Breakout game in not too much time. If you've already signed up with Scratch, you can share your game. If you haven't signed up yet, see Section 1, Video 4. On the website for this video series, you'll find links to a slightly more advanced version of this Breakout game, and you're welcome to remix that file and keep experimenting. We're just getting started in this video series. Coming up in Section 3, we'll work on a fleshed-out collect and avoid game. Section 3 implements a basic catch and avoid game. We'll catch fruit for points and avoid donuts for health. We'll even control the cat with a webcam. If you completed Section 1, you ended up with the start of a catch and avoid game, so some of the next few minutes will be a review. After we control the character, we'll add falling treasures and threats. We'll work on score and health. We'll reskin the sprites in order to get some more visual variety, and then we'll experiment with controlling the cat not with the keyboard but with a mouse and even with a webcam. I'm already signed in to the scratch.mit.edu website, and I will create a new project. To build a collect and avoid game, we start with a stage with the default sprite that we're about to control. We'll assemble a stack of blocks that will move the sprite to the right when we touch a key. From the motion palette, I'll drag this Move 10 Steps block and put it here in the script assembly area. We need to tell Scratch to perform this action when the player clicks the right arrow. So from sensing, we'll take key right arrow pressed. In order to assemble these blocks in a meaningful way, from control, we'll take an if-then block, which has a condition. The condition we're checking is the right arrow key pressed? And if so, we'll do what's inside this block. What we want to do, of course, is move the character 10 steps. I will start the process of checking whether the right arrow key has been pressed when the player begins the game by clicking the green flag. I want Scratch to check this condition over and over again. So from control, I'll get a forever block. I'll tuck that here under the green flag, and I'll slip this condition inside the forever block. And now when we run the program, and I tap the right arrow key, the cat moves to the right. The process for moving to the left starts out just as you would expect. We'll add another control if-then block. From sensing, we will get key left arrow pressed. And from motion, 10 is in this direction, so we'll pick -10. Now when we run the game, left arrow moves the cat left, right arrow moves the cat right. But the cat is walking backwards. How do we get the cat to face the direction it's moving? Here in the Sprites panel, we'll click this eye icon. Here we can see the rotation style. By default, the sprite is set to rotate like it's doing a cartwheel, and I can use this control to show you what a rotating cat looks like. If I select this right-left arrow, and I rotate the cat again, watch what happens. Now the cat is facing to the left, and the cat is facing to the right. So we've simplified the motion of the cat so that instead of doing cartwheels, he just does a mirror image flip. There's one more step though. We need to tell the cat to face in the direction of the arrow key. So here, in the section of the code that runs when the right arrow key is pressed, I'm going to drag this block, which says point in the direction, and as it happens, right is 90. Then in the area for the left key, we will point in direction -90. And now when we run it, the cat is moving backwards, but that's perfectly sensible because here we've told the cat to move -10 steps. Now that the cat is facing this direction, forward is this way. We want to move the cat in the direction that it's facing 10 steps. And now when we run it, I'm hitting the left arrow and the right arrow. Let's improve that animation. In the Costumes tab, we see that there are two versions of this cat. If we alternate between them, we get a walking animation. So in the Scripts tab, I'm going to pick from the Looks palette, Next Costume, put that there, and I'll do the same thing for when the cat is moving left. And now when we move the cat, we have a bit of a walking animation. I find that 10 steps is a little bit too small, so I'm going to increase the amount he moves to 20 in either direction. And now we have a little bit more realistic walking animation. We now have a character who can move left and right, and in the next video we'll supply some incentives for our character to move. Now that we can control the horizontal position of our character, we need to provide the player with a reason to move around. We'll add treasures to collect and threats to avoid. Because our game will have our character moving around the screen, I want to make sure that when the game begins, the player will always start in a particular location. We'll start the player near the ground. This block right here will always display the current XY location of the player, so I'm just going to grab a copy of that block, put it here, and now when I run the game, each time I run it, the player will be reset in that area. I've been calling this cat player, but Scratch has given this character a generic name. Let's rename it something meaningful, which is always a good programming practice. Now let's create something for the player to interact with. We will choose a new sprite from the library. I'm going to choose a thing. We'll pick an apple, place the apple here. If you've already completed the Section 1 tutorial, this will be a bit of a review, but that's okay. It's worth repeating these things. When the player clicks the green flag, we want to start a process that will repeat forever. We want to do an if-then statement that checks to see whether the apple is touching the player. If the apple is touching the player, then from looks, we want to get hide. And because we need to tell Scratch that this game should begin with the apple being visible, we'll start with a show block there. Okay, that works as we expect. If you remember from section 1, we instituted a brief delay so that when the cat was overlapping the apple position, we didn't accidentally trigger the disappearance of the apple before we really wanted to. I explained that in more detail in section 1. Now let's add a threat. In the New Sprite panel, again, we'll pick another object. We'll take a donut. Place it over here. As you can see, the donut has no scripts attached to it. We want to make the donut disappear just like the apple did. And we can do that pretty easily by going over to the apple, dragging this set of code, and dropping it on top of the donut icon. So now we have this set of code here. Okay, that works just nicely. We want these objects to fall from the sky, so we have things to catch and avoid. We'll start by making the donut fall from the sky. I'll reset the game, and we'll put the donut up here. Again, we want to make the donut fall from the sky. So I'll place the donut up there. That's where the donut will appear. Here in the Motion tab, you can see this X and Y coordinate shows me that this is X coordinate minus 118 and Y is 223. I'm going to drag this block and make the donut begin here. Let's add some code that makes the donut drop. From Motion, let's get a change Y by. Put that here inside the forever block, but not inside the if-then block. We will change Y by minus 20. As you can see, the donut fell to the ground. This code is live. The changes that I make to this stack of scripts will be executed immediately. We also need to add code that makes the donut jump back up to the top of the screen when it hits the ground. So let's get another control if-then block. We'll put it here. And what we want to check is whether the Y coordinate of the donut is less than the bottom edge of the screen. The bottom edge of the screen, as you can see from this readout here, is minus 180. So we want to get the operator block. We'll get the less than block. From Motion, we want to get the Y position of the donut. If it's less than, we'll go minus 170. We want to have the donut go to a particular location. I'm not going to drop the go-to block in just yet. We want the Y to be 223, but we don't want the player to be able to predict exactly where the donut will appear across the top of the screen. We want it to appear somewhere from a minus 240 to 240. So what we want to do is pick the operator, which is pick random from an X value of minus 240 to 40, and we will drop that in here. Now the donut is appearing in random places. Now notice after the donut hit my cat, the donut disappeared. So we also have to make sure that after we move the donut, we show it again. There we go. So now I can try running away from this donut. We basically want the apple to do the same thing. So I'm just going to take this whole block of code. I'm going to drop it on top of the apple. It was dropped over top of the existing block of code that was part of the apple. I'm going to delete that part of the code. And now the same thing. We should see the same thing happening. There we have an apple and a donut. My goal then would be to try to catch that apple without being hit by the donut. In the next video, we'll implement score and health so that touching these different objects will affect the state of the game in different ways. For now, we'll just focus on making the player react to the threat. We'll provide both audio and visual feedback. With the player selected, let's go to the Sounds tab. The game comes with a sound, but let's instead import a sound from the library. We'll get a human sound, this cough male. That will indicate that the donut is harmful. So from scripts, we go to sounds. I'm going to grab this play sound cough male. I'm not going to attach it anywhere yet. From looks, I'm going to take the change color effect by, but I'm going to change this option. I'm going to change the brightness by minus 50. Then I'm going to wait a bit, and then I'm going to clear graphic effects. And here's what will happen. Now we need a way to trigger this event. Right now, the donut knows when it's touched the player, but there's no way yet that the player knows whether it's touching the donut. I could add another if touching block to the player. Since the coughing and dimming is something that affects the player, it makes more sense for me to make that behavior live here on the player, and have the various threats we might encounter in the game world trigger that event. So first let's fire the trigger. Let's go to Events. I'm going to take this broadcast message block. I'm going to create a new message called Player Hit. And that message is going to be sent when the donut touches the player. Over here in the player, I'm going to add a When I Receive Player Hit block. That works pretty nicely. Let's make the cat respond to the apple in a different, positive way. First, I'll rearrange these blocks a little bit. Then from the apple, we will create a new message, Player Score, and in the player, when I receive Player Score, I'm going to make the cat jump up a little bit, and then we'll play the sound meow. We'll wait not as long. This is a shorter sound. And then we'll return the cat to its previous Y location. So let's see how that works. There we go. I'm getting a little bit better at this. Now we have the main parts of the game working. I think we're actually colliding with these objects too frequently. Too much of the game depends upon luck. So I'm going to try to resize these objects a little bit. This is a shrink tool. I'm going to click each of these objects 4 times. And now if you go to the Looks tab, you can see the size is 80%. So now when I run the game, there's a little bit... Yeah, I've got a little bit more control. Okay, maybe I spoke too soon. Okay, well in the next video, we'll implement score and health. Now that we can control a character with the keyboard and we can interact with falling objects, in order to turn those elements into a game, we're going to implement score and health. We'll set up the game so that the player wins after collecting 10 treasures and loses when the player's health reaches 0. With the player selected, we'll go to Data, we'll create a new variable and we'll call it Score. Under the green flag, we will start the game by setting the score to 0. And here, every time the player scores, we will change the score by 1. Now we want to end the game with a victory message when the player's score is greater than 10. So from control, let's get an if-then block. From operators, we'll get an equal block. The condition we're going to check is if the score is equal to 10. If that's true, then what we want to do is from looks, we want to say, you win. We'll pause just a bit. I'm going to scroll this so the whole thing is visible. And then we will stop all the scripts in the game. Now let's implement health. We'll make another variable, call it health. I'll scroll back up. We'll start the game by setting the health to 10. Drag this a little bit so I can see my blocks a little easier. Then, under the player hit, we will change the health by -1. And after we've done that, we'll have another if-then block. We'll have another equals block. We'll check to see whether the player's health equals -1. And if the player's health is negative, then we will say, you died. We'll wait a little bit, and then we'll stop all the scripts. Let's try it out. How am I doing? Ah, did I win? I did end the game in victory. You can tell because the score reads 10. The game starts abruptly and it ends abruptly too, really too abruptly. Now we won't have time to cover it in this video, but in the last section in this series I'll show you how to add some more polish. A start screen with instructions, multiple levels. In the next video, I'll show you a surprisingly easy way to get some variety in your game world. So far, we can control our cat with the keyboard, and we have things to collect and avoid. In this video, we'll add a bit more visual variety by making the apple sprite look like different kinds of fruit. We'll select the apple sprite and the costume tab. I'm going to choose a new costume from the library. I'll pick these bananas. I'll also pick a little orange. Notice this sprite that we've called apple now looks like an orange or a banana or sometimes an apple. Let's rename this sprite something more appropriate like fruit. And here in the scripts tab, this is where we reset the fruit after it disappears. So from the looks palette, let's pick next costume. Okay, so we have apple, banana, orange, apple, banana, orange. It's a little variety, but it's kind of predictable. Instead of this next costume block, let's switch costume to. We can select a costume by name, but we can also identify a costume by number. There are 3 costumes, numbered 1, 2, and 3, and we already know how to pick a random number, so we're going to drop that in here. Pick a random number from 1 to 3. Now when we run it, we're getting some random fruit. Oh boy, he's not doing too well. You could change the donut the same way if you like. We've given the apple the ability to take on different costumes. This strategy works best when the variety is strictly visual. That is, the behavior of this object is the same no matter what it looks like. If we were trying to create a different object with unique properties, like a power-up or a monster that moves in the direction of the player, then instead of displaying a different costume, we should create a different sprite altogether, with its own separate stack of scripts inside. Now we have a game that basically works, but in our next video, we'll tweak the controls to make it even more fun. So far, our game is looking pretty good. But let's engage the user a little bit more. Let's make a version of this game that's controlled by the mouse, and a version that's controlled by the webcam. We'll work with the player in the Scripts tab, and first we will disconnect this part of the script, which is what deals with the keyboard input. And we'll instead replace it with this one block, which is very useful, go to mouse pointer. You can see what that does. In fact, most of us are so good at mousing that this game would really be too easy. I could add more obstacles and power-ups so that the game gets progressively harder, and in fact in the last section in this video series we will do something like that to a maze game. But for now I want to show you a new feature in Scratch 2.0, and that's video control. So we'll take this mouse pointer thing out of the way for now, and in sensing, we'll get this block turn video on. We'll put that there above the forever block. I'm going to drag the cat to where we can see it. And just so we don't go crazy for a moment, I'm going to disconnect the code from the fruit and from the donut. And now when we run the game, you're going to get a dialog box that double checks that it's okay to access your camera. Hello there. We'll use this video input to control the cat. We'll make it point in the direction that I wave. Obviously, to make this work, you'll need a webcam, you'll need some decent lighting, and you'll need a background that doesn't have a lot of motion in it. From motion, we'll work with point in direction. From sensing, we will get the video direction on this sprite. And now when we run it, go. When I wave at the cat, he changes direction. Move it here again. My chin, I can make a move. There. Now let's add a motion block to this forever block. We'll make the cat move in the direction, and this is, you can see why I briefly disabled the falling objects, because this is just a little bit too chaotic. Yeah, this is a bit much. Fun, but kind of hard to control. Okay, so let's tone that down. Scratch can also sense the amount of motion on a sprite, And so what we'll do is we will add a if-then block, and if, with a greater operator, if the video motion on this sprite is greater than 10, we will move the cat 10 steps. So that's how we'll assemble it. And now, the cat will only move when I give it a little nudge. Okay, and I can kind of grab the cat, I can kind of control it. With a little practice, I can control the cat with my fist. Okay, so let's go back to the fruit. I'll reconnect that code. The donut, I'll reconnect that code. And let's see what we get. Oh. Come on. I'm not doing so well. Okay, well, I feel much more engaged in this game. I can't just sit back and relax. My whole body is engaged in this game. All right. A game that uses video input this way would have to be very engaging to the user and very forgiving and have to give sort of a lot of feedback. Okay, well, I don't know about you, but I'm kind of exhausted from this section. For the next series of videos, we'll do a point-and-click adventure game. Change of pace. So far, we've created games that involve moving a few objects around on a single backdrop. In this video, we'll create several backdrops, and we'll use them in a point-and-click graphic adventure game. I'm going to create a puzzle with a locked door. The key will be hidden so that you can only find it when the lights are on. To make that part of the game, I need to start with a background image that includes a closed door, a light switch, and a hiding place for my key. We don't need the cat. Scratch has now highlighted the stage, and we can see we're looking at a backdrop. Now, if you're a better artist than I am, you could draw. Here's a door, here's a chair, here's a light switch. Okay, well, if you're a better artist than I am, maybe that's the route that you want to take. You could pose Legos, you could use screenshots from your favorite video game. You could do any of those things. But what I'm going to do instead, first I will clear this attempt at artwork. I'm going to use my web camera, and I'm going to take a picture of my office. Okay, I've already set my camera up in my office the way I want it, so you can see there's a door, there's a light switch. What I'll do is I'll start by turning the lights off, and I will save a picture. All right, so that's one picture. Now I'm going to create another one with the lights on, and I'll save that one. Okay, and then another one to represent the winning condition. We'll have an open door. All right, we don't need this default backdrop, this white backdrop anymore. We now have a starting version, a version of my room with the lights on, and then the lights on and the door open. In the next video, we'll start working with these images. Now we have backdrops that represent 3 different game states. We'll start working now on making clickable objects that we can overlay on those backdrops so we can trigger events within the game. When I play one of these games, what makes it fun for me is seeing what happens when I click on interesting objects. So I'm going to start by attaching a pop-up message about this mug. I'll start by clicking Paint New Sprite. I'm going to select the rectangle tool. I want to make sure that it's a filled rectangle, and then I'm going to draw a shape that roughly approximates the shape of that mug. Let's see how that works. Okay, it's much too small, but that's okay. I can click on the grow icon, and yeah, that works. So I'm going to drag this shape. I might, just for the heck of it, in case somebody clicks on the handle of the mug. Okay, so now we have a shape that roughly approximates the shape of the mug. I'm going to click on the blue eye, and it's always good programming technique to name your objects meaningfully. We'll call this mug. Now it looks pretty ugly like that. We don't want a big black object in the middle of the game. Let's add some code that will make the sprite transparent. From the Scripts tab, we click on Events. When green flag clicked, we will go to Looks. We'll get this block that says Set Color Effect. I'm going to change color to Ghost and set it to 99. which makes this button almost completely invisible. If we set the ghost effect to 100, it won't respond to clicks. Next, we'll create a pop-up message. From looks, we'll take the say hello for 2 secs block. We'll change that to something meaningful. When I click on this sprite, I want it to say, change it to 3 secs, it will say, empty, I've got to get out of here and get some caffeine. And we'll connect that with a when this sprite clicked. So when we run the game, the button turns invisible, and this message tells us what to do if we're not sure what we're supposed to do in this game. Let's turn our attention to the backdrops. To make our job easier, let's give them meaningful names. I'm going to call this one Lights Off. This one will be Lights On. And this one will be Door Open. We'll go back to the Lights Off area, and I'm going to create another sprite that's going to represent the doorknob. Paint a new sprite. Get a shape that roughly represents the doorknob and the keyhole. Drag that, put that over here. We'll make it a little bit larger. And in scripts, under it, I'll place switch backdrop to door open. As we did with the mug button, we also want to start this project by setting the ghost effect to 99. So we'll drag this script over here to the doorknob. Oh, let's actually rename this doorknob. Okay, that's good programming practice. Let's move these things around so we can see them a little bit more easily. And whenever we want a value to change during the game, we have to remember to tell Scratch what value we want to start out with. We just added a way that the game can change the backdrop, so we need to set the starting backdrop. Let's go to the stage. We'll get the when green flag clicked. We want our starting backdrop to be switch backdrop to lights off. Next, we'll follow the same basic steps to create a hotspot that will turn the lights on and off. I'll paint a new sprite. I'll get a shape that roughly matches the light switch. Place it over the light switch. Let's call this something meaningful. Let's make sure that we have this same ghost effect thing that happens here. And when this sprite is clicked, we will set the backdrop to lights on. When we run it, we'll see clicking the light switch opens the light, clicking the doorknob opens the door. Now, at the moment, when we run it, we could open the door and you see that also turns the lights on. We have a bit more programming to do before this puzzle is implemented very well. We'll reset the game. Now, clicking the light switch and turn the lights on makes sense. We probably should implement the ability to turn the lights off as well. So we'll want to make clicking the same button perform a different action. We can do that pretty easily, but there's a catch that I want to warn you about. Pay attention and you'll know what to look for in order to avoid a very common programming mistake. Okay, within the switch, let's assemble the blocks that we're going to need. From control, let's get an if-then statement. From operators, we'll need an equals block. And from looks, we'll get backdrop name. I'm going to drop that in there. So, instead of immediately switching the backdrop to lights on when the sprite is clicked, first we're going to check to see whether the backdrop name currently equals lights off. And if so, we'll switch the backdrop to lights on. That makes perfect sense. I'm going to duplicate this block, drop it here, and we're going to change it now so that this says, if the backdrop name is lights on, we want to switch the backdrop to lights off. Okay, it looks like that should work. Let's run this. Wait a minute. I'm clicking, but it's not working. As you can see, the lights always stay off. Now, when a program does not behave the way we expect, usually it's because the computer is obediently doing exactly what we told it to do, and we just didn't tell it the right thing. We need to find the bug, the problem that's keeping the program from behaving the way we want it to behave. When we click the sprite and the lights are off, then this block first checks to see, aha, yes, I understand what you want me to do. You want me to switch the backdrop to lights on. But then this next block immediately says, aha, the backdrop name is lights on. And so Scratch will obediently switch the backdrop back to lights off. And we'll never see the lights go on because this will happen so quickly. So instead of two stacked if-then statements, what we need instead is an if-then-else block. And we're going to say, if the backdrop name equals lights off, then switch to lights on. Throw this away. Only if this statement is not true does Scratch bother to check this second condition. And the second condition is if the backdrop name equals lights on. So let's run that and see if that works. And it does. The more stuff we want our player to do in the game world, the more coding like this we have to do on our own. This is where the rubber really meets the road. We've started to see how to get simple things to happen when you click a hotspot, and we've seen how to make the same hotspot perform differently based on the status of the game world. In the next video, we'll keep building on that as we make our objects work together to form a simple puzzle. Now we have clickable hotspots that can pop up a message and change the game world. But right now, it's hardly a challenging game. Let's link objects and events to create a puzzle. We'll use more if-then statements with true-false questions in order to trap our player until he or she wins the game. This is actually easier than it sounds. We'll need a hiding place for a key. We'll need a way to keep track of whether we found the key, and we'll need to prevent the player from going through the door until it's been unlocked. We'll start with the hiding place. I will click on Paint New Sprite, I'll get the Rectangle tool, and I'm going to create a shape that's roughly the shape of the cushions in my chair, which is where I lose things all the time. I'll click the Grow icon to make that shape. And with this blue icon, click, I'll rename it Cushions. From Scripts, let's go to this switch. I'm going to drag this common stack of blocks to Cushions, and now the cushions will also be set to almost invisible when the green flag is clicked. Now we need a way to keep track of whether the key has been found. We'll do that by creating another variable. A variable is just a named space where we can store information and read it back later. We're going to call this variable key hidden. We need to give it an initial value. So here in the cushions object, we will set key hidden to equal a default value of true. What do we do with this? Well, with the doorknob sprite selected, I'm going to get a control if-then-else block. I'll put our existing switch backdrop to door open block in the else branch. And from operators, I'll take the equals block. And the thing that I'm going to check is whether the variable key hidden equals true. If so, I want to print out the message, it's locked. Where could my key have gone? And I'll make that 3 seconds. And we'll put that here. So now, when we start the program and click the doorknob, first the game will check to see whether the variable key hidden equals true. If so, we get a message saying the door is locked. We need a way to change the key hidden variable to something other than true, so that this branch will be called. With the cushion sprite selected, we're going to get an events when this sprite clicked. From control, if then else, we'll get an equals operator. We'll get the data key hidden. We're going to check to see if key hidden equals true, which is the default value. If we click the cushions when the key is hidden, we're going to set key hidden to equal false. We'll print a message that lets the player know the key's been found. So that's where my key was. And we'll get another say block so that if we click the cushions again after the key's been found, we get a message that simply says, nope, nothing else. So let's try it. Run it. Door's locked. Click here. So that's where my key was. I click here again. Nope, nothing else. Now when I click, aha, we've escaped the room. Well, let's make the puzzle a little bit harder. Let's say we don't find anything useful unless the lights are on while we search. We'll need another if-then-else block from the control. We'll get another equals block from operators. The condition we are checking is whether the backdrop name equals lights off. If the backdrop name equals lights off, the only thing we want to happen is for the Scratch to print out, I lift up the cushions, but it's too dark to see what's under there. We'll make that 3 seconds. And we're going to take this whole section, we're going to tuck that into the else branch, and we'll assemble it this way. So let's run it now. I can turn the lights on and off. I lift up the cushions, but it's too dark to see what's under there. Turn the lights on. So that's where my key was. Click again, it says nope, nothing else. I could turn the lights off again, and then look under the cushions again, I still see nothing. But now, with the door unlocked, I can escape. We've used a variable to keep track of the state of a hidden object. We've used that variable to determine how other objects behave when clicked. We've seen how it's possible to turn a simple action, clicking a button to open a door, into something dependent on other details, such as what backdrop is currently displaying, and whether a hidden object has been found. In our next video, we'll add some more visual feedback and we'll work on the win game state. We've added a locked door puzzle, but so far we've only used the word key in text messages that the player reads. There's no key object. Let's make a key sprite so that the player gets some visual feedback during the game. The Scratch library happens to come with a key graphic. So let's go to Choose Sprite from Library, Things, Key. I'll drag the key to where I want it to appear when the player has found it. Let's put it here. And with the key selected, we'll go to Events, When Green Flag Clicked, and then Looks, Hide. So when the game begins, the key is hidden. Now it's here in the cushion script that we determine whether the key is still hidden. There's no block that I can drag from anywhere in this palette that will allow me to change something about the key from here within the cushions. Instead, I have to send a message. When I broadcast a message from the cushion sprite, I can set up the key sprite to listen for that message. So let's do that. From Events, we will broadcast the message. We'll add it here, which is the part of the stack that determines the key's been found. I'll create a new message, and we'll call it Key Found. Back in the key sprite, we will add a when I receive key found, then I will show this sprite. If we run the game now, turn on the light, and there's the key. Now after I've used the key on the door, this key is still visible. So that we don't clutter up the screen with useless objects, let's get rid of the key. In the doorknob sprite, we'll take Events, Broadcast, we'll have a new message, Key Used, and then from the key, when I receive Key Used, then we'll hide the key. And to provide just a little bit more feedback, here in the doorknob, at the time that we use the key, let's add a message that says, I'll just use my key. Okay, we've provided a little reward in the form of a key that appears that informs the player that some progress is being made. The sight of the key on that screen is not just eye candy, it also hints that the player should do something. The player might try clicking on the key, so we could do something like, when this sprite clicked, say, I should try the door. And that'll tell the player what to do. In our next step, we'll end the level. Our game works. We can escape my office. If we want to expand the game by adding additional adventures that take place in the hallway, we'll need a convenient way to reset this level. But first, let's end this level in some kind of satisfying way. We can't really end the level with the door open like that. If the point of the game is to escape the room, well, we're denying the player an important satisfaction. So we're going to add another clickable hotspot that lets the player go through that open doorway. I will paint a new sprite. I'll get the rectangle tool, I'll set it to a filled rectangle, try to roughly get the shape of that doorway. An eraser here, chop out this section, that section. Okay, good enough. We'll call this doorway. We'll go to one of the other sprites. We'll go to the Scripts tab. We'll get this standard when green flag click block. But since I don't want the user to be able to trigger the escape routine until the door is open, Unlike all the other blocks, when this green flag is clicked, I want to hide this script. And from events, when backdrop switches to door open, then I will show this. And when this sprite is clicked, from looks I'll get I escaped the room. Next we're going to create a level loading backdrop screen, and we'll code all the objects we've created so far to hide themselves whenever the level loading backdrop appears. Once we've done that, we'll code every object so that it automatically hides itself whenever the level loading screen is shown. As long as we code each new object properly, it will be a very simple thing to shut down a level and start up a new one. On the stage thumbnail, I will paint a new backdrop. I'm going to use the text tool. I'll get some green text and I will type level completed. And I will name this backdrop level completed. And now I'll pick the first sprite that I created under scripts and events. When the backdrop switches to level completed, I will hide this sprite. And I will drag a copy of this to the doorknob, the switch, cushions, key, and to the doorway. Now all the objects in the game will hide themselves when we show the level completed backdrop. So let's go to the doorway, and we'll make sure that we switch to the level completed backdrop. Light switch, find the key, use the key, escape the room. Now we have a complete game with visual feedback that encourages the player to complete the last few steps that lead to this final win state. If you'd like to expand the game by adding more levels, see the final section in this series, which covers how to start up another level after you've closed it down like I just did. In our next video, we'll get back to a Twitch game, a 2D base defense game that will get harder and harder as you keep playing it. In our next video, we'll make a base defense game. We'll shoot at incoming targets. The core mechanics of a base defense kind of game are pretty simple, so in this series we'll put together a basic game pretty quickly, and then we'll move on to increasing the difficulty and adding visual variety to our game. First we'll start by creating a home base and projectiles, then we'll create inbound targets, we'll keep score and end the game, we'll increase the difficulty, and then we'll reskin the sprites for some visual variety. I'll start with the default project, and we'll delete the cat. The stage is automatically selected. I'm going to choose a backdrop from library. I'll pick base and a star field. Now I'll choose sprite from library, and for our base, we'll pick up the Earth. Now we need a target selector or a reticule. I'm going to paint a new sprite. Now you could just do crosshairs. I'm going to make a peace sign for my target selector. I'm going to get the circle button, I'm going to make the line a bit thicker. I'm going to hold down the shift key as I draw this ellipse to make it a perfect circle. Place it in the center. I'm going to zoom in a bit so I have a better look at it. Arrow keys, I'll adjust the position. We'll get a vertical line. Make 2 diagonal lines. Let's try filling this and giving it a little bit of a shade. I'll pick a goldish kind of color for the light color. I'll click here, the darker color, make it a little bit darker. Click this, and see this shade button down here? There we go. Okay, so the center of this is a little bit brighter, and I'll call this that's the reticule. Now we need to make this reticule follow the mouse around. So from scripts, we'll take the when flag clicked, we'll get a forever block from control, and then from motion, we'll go to mouse pointer. Now we have a pointer. Now we'll create a projectile. I'm going to paint a new sprite. I'll name this projectile, and I'm going to draw a heart. You can, of course, draw whatever kind of missile that you want. I'm going to get the circle. I'm going to make it a filled circle. Let's give it a nice mid-red color. I'm holding the shift key down. I'm going to draw one circle to the to one side of the crosshair. I'll use the stamping tool, select this area, and then move it over here. Go. Then I'll use the line tool, draw the point, and I'll make it a solid fill. I'll fill it in. Okay, now we have a heart. And I'm going to zoom in on this a little bit. And I'll just adjust this a little bit. Eraser tool, trim that. It looks a little better. I'm going to get a bit of a darker red color. We'll give this heart a little bit of a shadow here. And a little bit of a highlight. Good enough. Now we'll make a mouse click trigger the heart projectile. With the projectile selected, we'll go to Scripts, from Events. When flag clicked. Looks, we start off by hiding this projectile. From Control, we get a forever block. We'll also get an if-then block. We'll sense whether the mouse is down, and if so, we will show the projectile. We will point the projectile towards the mouse pointer, and then outside the if-then block, we'll move 10 steps. Well, let's test it out. Okay? Well, that's a little weird. We never did tell Scratch where the projectile is starting from, and this is also something that's weird. If I hold the mouse button down, I can steer this projectile around. And, who knows, maybe at a later level you'd want to have some kind of guided smart missile as a power-up. But for now, let's just make the missiles always start on Earth and travel in a straight line. As it happens, we can solve both those problems here in the projectile by adding a Go to Earth block. Go. Notice that when the projectile hits the edge of the screen, it sticks. Let's add a script that will check whether the projectile is touching the edge of the screen, and if so, hide it. So from Control, an if-then block. From Sensing, touching edge, and if it is touching the edge, then we hide. There we go. I'm going to add 2 minor tweaks. I'm not actually creating the physics of shooting a heart-shaped missile into space. That heart is really just an icon. I want the shape to stay recognizable as a heart, no matter what orientation, no matter what direction I'm firing. So I'm going to click this blue icon. I'm going to change the rotation style to this point, and now the heart will always stay in a vertical position. Next, I want to add a visual effect that will look nice and will also make the game a little bit harder. I'm going to make the projectile shrink in size as it moves away from the base. This will make it harder to shoot faraway targets. It will also increase the illusion of depth. We'll seem to have a less crowded playing space, and it will almost be as if we're looking at space through a fisheye lens. So we'll need this set size block. We'll put it here under the move block. From operators, I want the multiplication block, and the size will be the current size times 0.95. And now, what else do we need to do? Well, since we are changing a value while the program is running, we need to tell Scratch what the starting value ought to be. So we'll need another set size to, and after we show the heart for the first time, we'll set the size to 100%. We've already got about half the mechanics of the game working. In our next video, we'll add incoming targets that we need to defend against. Let's jump right in and create some inbound targets for our base defense game. We'll start with some fairly large, fairly slow invaders. I'm going to use a rocket ship that comes with the Scratch library. Choose Sprite from Library. I'll go to Space, and we'll use this spaceship. Whoa, okay. That's way too big for the scale of my game. So, from Events, when the green flag is clicked, we'll set the size to 25%. Okay, that's a little bit better. Now from Control, we'll get our forever block. We will point towards the Earth, and then we will each turn move 3 steps. Okay. Couple problems there. First, notice the rocket was floating on its side. Now, that is not actually something that we can fix with these rotation style buttons. Actually, what we need to do, we have to adjust the sprite's costume. Now, you may have noticed that here in this editor, we have a very different set of tools. This is vector-based graphics. We can zoom in very closely on this image, and you can see the lines all remain very smooth. If we take one of these bitmapped images and zoom in, you can see the image gets very blocky. This bitmap shape, a bitmap image is what you would want to use if you want a photorealistic editor. These bitmap tools may be a little bit easier to use, but if you want something that's more like a cartoon, then these vector graphic tools in Scratch 2.0 are really powerful, and they're really a significant advance over Scratch 1. Okay, with the Select Arrow tool, I'm going to click on the shape, and see this handle right here up above the image? That's a rotation handle. I'm going to grab that. I'm going to rotate this image so that it's roughly facing 90 degrees to the right. Now let's tell our incoming targets where they're supposed to come from. I'm going to go back to scripts. I'm just going to collect a couple bricks. I'll put them together and I'll show you what I'm going to do with them. I'm going to, from motion, go to Earth. Then I'm going to point in direction. From operators, I'm going to get the random. And what we're going to do is pick a random angle from minus 180 degrees to 180 degrees, which is how Scratch defines a circle. We're going to point this sprite in a random direction. Then we're going to move this sprite 300 steps in whatever direction it is. Then we're going to make the offstage sprite turn around and point back to the Earth, and then it will slowly progress inwards. So let's pick the random angle from minus 180 to 180. Then we will move 300 steps, and then we will point towards the Earth, and we'll put this here. Now notice I now have 2 blocks that say point towards the Earth. I'm going to move this one away. We only need one of those. So to recap, what happens when the game starts? We set the rocket to 25% of its size. We move the rocket to the Earth. We point the rocket in a random direction. We jump the objects 300 steps in that direction so that it's now off stage. Then we turn that object around and point it back towards the Earth, and then we slowly start moving it towards the Earth. Let's see how that works. All right, well, the rocket sails right through the Earth. Well, we need to code some collisions. The rocket hitting the Earth will end the game. But first, let's code a collision between the incoming rocket and our heart missile. From control, we'll do another if-then block. We'll sense whether our rocket is touching projectile. In a later stage of the game, we would probably want more than one incoming hostile coming in from different directions. But for now, when we hit the target, we'll just move it to a new random location and let the same rocket ship come in again from a different direction. So what we'll need to do is, when the rocket is destroyed, we can hide it, but what we really want is just to move it off screen. And how do we move it off screen? Well, we point it in a random direction away from the Earth, we move it 300 steps in that direction, and we point it towards the Earth. But what I just described, that's this block of code that we already created here. I could copy each one of these bricks and put them inside here. Well, let's do that. I'll get rid of this part. So here we go. Yeah, I could do that, but these blocks duplicate these blocks. DRY, don't repeat yourself. That's an important coding principle, and this is a good opportunity to mention it. If later I want to edit the game so that targets only come down from the sky and not up from the ground, well, I'd want to make that change in one location only. I wouldn't want to have to remember to make changes in 2 different locations. So let me introduce a new feature in Scratch 2.0, which is creating a custom brick. In other programming languages, this would be what we call a subroutine. It's a little section of code, kind of like the refrain in a song, that we reuse whenever we need to. We'll create a new instruction that calls a short stack of bricks, and we will do that by going here to More Blocks. Let's make a block. I'm going to call it Reset. Okay, now to define reset, I'm going to take this stack of blocks that I'd been reusing, and instead of that stack of blocks, I'm going to just insert this reset block. And I'm going to do the same thing with these guys. This reset block is almost kind of like a nickname that says, do all this stuff that has been defined as part of the reset block. So now all I have to do is change this behavior in one location, and I can call it from this stack of blocks. Well, let me make a change right now. I'm going to add go to earth here. I only had to make that change in one location, and let's see what happens. So now, when I shoot the rocket with the rocket moves to a new location and keeps coming in. Now we've created an inbound target that we can neutralize with our outbound projectiles. We've also used a custom brick to create a subroutine that resets the incoming hostiles. But so far, these are just animation. There's no scorekeeping or consequences for missing. In our next video, we'll make this into an actual game. So the mechanics of our base defense game work, but we need to keep track of the game state so we can find ways to keep the player more involved. And we'll do that by keeping score and coming up with a threat that ends the game. And the process here is the same as we've seen in other videos. We'll go to Data, we'll make a variable and call it Score. Now we'll need to set the score somewhere, and I think it's logical for us to make our base be a sprite that keeps track of the score. So with the Earth selected, we'll go to Set Score to 0. From Events, we'll take when the green flag clicked. Let's assemble those together. And now we'll increment the score each time we destroy an incoming missile. So we'll go to the target, our spaceship, and we'll add a data change score by 1 block, and we'll put that right here. Okay, so now we have a way to increase the score. You can see that score button in the upper left-hand corner is increasing, but when we miss the target, it just sails right through the base. We need to make this missile a threat. So here in the scripts for the incoming target, we'll need to check to see whether we've collided with the base, and if so, we'll broadcast a message game over, and we'll print a little message that ends the game. So from control, let's get an if-then. From sensing, we'll get a touching, and we'll set that to Earth. And then from control, we'll get a stop all block. And we'll put that right here inside that forever block for the incoming missile. Now when we run this, now we will see that when the missile touches the Earth, the game just stops. That stop is a little bit abrupt. We really need to find a way to make this ending look a little better so it's more pleasing to the player. So from this incoming spaceship, we will broadcast a message that will enable the Earth to print a message ending the game. So let's get Events, Broadcast. We're going to set up a new message, Game Over. And instead of stopping everything, we're just going to stop this script, because we don't want to end the whole game until after the Earth has printed a final message for us. So now we'll go to our Earth base, and we will, when I receive the game over message, we're going to print 2 little messages. The first one is going to say, "Oh noes," and the second one is going to say, "I is exploded." And then we will, under controls, stop all the scripts, and the game will really end at that point. So let's see what we've got. "Oh noes, I is exploded," and then now the game actually ends. So we now have a game that will send us an endless supply of incoming missiles. So we've seen this broadcast block before in many ways, but what's new is this custom block. The game works, but it's kind of boring. It does keep score, but the game never gets any harder. In our next video, we'll look at a way to make the game get harder, which will keep the player's interest for a little longer. Our base defense game works, but it's very easy. Any good arcade game needs to get progressively harder. We will use cloning so that multiple incoming hostiles can be on the stage at the same time. Okay, first we will adjust our existing code. Instead of using this spaceship sprite itself, we will be using a clone of this spaceship. Each clone will operate independently, and to start out with, we'll still have just one rocket active on the stage at a time, so at first cloning seems like a lot of work for no obvious benefit. But once we start adding multiple rocket ships, you'll see the benefits of doing this. So, with the spaceship selected, we'll get a new event when green flag clicked, and then under control, create clone of myself. Now what we need to do is take this whole stack that was under when green flag clicked, and we'll put that under when I start as a clone. So we'll reorganize. We don't need that anymore. We'll move this over here. Now the work is being done by a clone of the original rocket ship. And when we run this, we'll see, well, look at that. There's a static version of that original rocket ship that's stuck there. All we have to do is just go back to the spaceship, and after we create a clone of myself, we'll just hide that original one. Now, we'll also need to make sure that when we start the clone, that it's visible. And I guess we'll put it right there. So that should work now. Okay, so now we have one clone of the rocket ship doing all the work that the original rocket ship did before. So let's set it up so the game gets harder. Just when the player is feeling confident, let's add another clone. So we'll go to the spaceship. We'll take a forever block. We will wait 15 seconds. We can create a clone of myself, and then we'll wait 15 seconds, and then the forever loop will repeat, and we'll create a clone of myself and wait, and then it will continue forever. We only need to hide the original once, but we'll forever keep adding another rocket ship every 15 seconds. So let's see how that goes. All right, so far so good. Yeah, I'm pretty good at this. This is boring. This is boring. Oh, okay, it's not boring anymore. It's not boring anymore. It's not boring anymore. It's not boring anymore. It's not boring. Okay, well, there we go. You might need to tweak the speeds or the sizes or the timings, but I think you'll find at this point that surprise that comes when the extra rocket ship appears makes this game more interesting. It's interesting enough to keep a player's interest longer than just a completely flat game that doesn't get any harder. Now, I don't know, maybe you are bored of rocket ships in space. In the next video, I'll show you how you can completely change the feel of your game pretty quickly by reskinning all the images. That is, we'll reuse all the code, but on the fly we'll change the costumes in the backdrop to give the game a completely different theme and to give the next level some variety. Now that our base defense game works, we can reuse all the coded mechanics with just about any graphics to give a very different feel to the game. So I'm about to rework all these costumes so that instead of a science fiction themed game, we're going to play a game in which we will be defending a fire hydrant from incoming dogs. So we'll start by adding a city backdrop. We'll go to Stage, Backdrops. I'll click Choose Backdrops from Library. From the city theme, as it happens, Scratch has a really nice Metro 1 backdrop that will be a nice setting for us. Now, the Earth looks a little bit silly floating on this backdrop, so we need to change this now to a hydrant. Scratch does not come with a hydrant graphic, but I Googled earlier for hydrant clip art. I found this one. I saved the image to my Downloads folder, and then here in Scratch, I will upload a costume from the file. I'll upload this fire hydrant costume. Now, this fire hydrant costume is much larger than the Earth. I can change the size of the costume. The easiest way is to convert this bitmap costume to a vector. I'm going to zoom out a little bit. Now, when I click on this in vector graphics, I've got these handles that I can move in and adjust the size of the image. I also want to make sure that I set the costume center so that it's in the center of the object. So now here, I can click back and forth between two different costumes for this same object, and we'll be using all the same code. I guess the next thing that we'll change is instead of incoming spaceships, we'll go to costumes, and we will upload a puppy image from the Scratch library. There just so happens to be a cute little dog puppy image, and see that puppy is a little bit bigger than the rocket ship. So I will again convert that to vector. I'll select the image, I'll drag this handle in, and then I will reset the center, and now we'll check. Okay, so those two sizes look about comparable. Instead of firing hearts, what will distract the dog? Well, let's go over to things, let's fire a baseball. And again, we'll check the size. The baseball is a little bit large. The baseball is already a vector image. I'll drag one of these corners down, and then I will reset the center, and let's see how that goes. That looks about right. Now, instead of a peace sign, well, what will interest dogs? A little bit earlier, I searched for some dog bone clip art. I already downloaded that. So I'll create a new costume. Oh, look at this. That just says Costume 1. Why don't I rename this usefully? We'll call it peace sign. And now we have that weird thing where I need to select this little bit of art in the upper corner. I really don't know why it does that, but it's gone now. Okay. So the center of that image, that works nicely. Okay, so let's upload the new costume from my downloads, and it was this dog bone, and that is huge, so I've got to shrink that down quite a lot. Drag these corners down, readjust my center. Okay, so we should now have complete game. All right, our next step will be to create a mechanism that allows us to switch between levels. And we'll do that, we'll click on Stage, Scripts, we'll add an event when green flag clicked, and we will tell Scratch that when the game begins, we want to change the backdrop to the default, which is not Metro 1, but stars. Now we could add a similar when green flag clicked switch each of these items to the costume that we want, but there's another way we can handle that. There's actually an events that will pay attention when the backdrop switches to a particular backdrop. Things can happen. So we'll go here under the base, and we will say when the backdrop switches to stars, we will change the costume to Earth. Likewise, for the target selector, backdrop switches to stars. We want to change the costume to the peace sign. Our projectile, we will again, when the backdrop switches to stars, costume to, well, it just says Costume 1. That should be, I should name that better. I should call this Heart. Lazy programmer, didn't name your resource. Okay, so back to scripts. We'll need to change this to Heart. And then when the backdrop switches to stars, Costume 2 is the spaceship that we want. So when we start, everything is back to the way it was initially. Now, how then do we trigger switching to the alternate cityscape? So first, let's set up a counter that checks the score, and then when the score equals 10, it'll change the backdrop to the Metro 1 cityscape. And we'll do that here in the Scripts tab under Spaceship. We'll get an if control block, put it right in here, right after the score goes up, and we'll get the equals operator. We'll get from data, we'll get the score, If the score equals 10, then we will switch the backdrop to Metro 1. And then now what we need to do is I'm going to duplicate this. When the backdrop switches to Metro 1, I want to change the costume to dog. And then in the projectile, we'll duplicate this. This is already listening for when the backdrop changes to Metro 1. We'll change that to baseball. Target selector. The backdrop switches to Metro 1. Change it to bone. Base. And the backdrop switches to Metro 1. We'll change it to the fire. So let's see if that works. Okay, one last change. Let's make the incoming targets so that they start off small and get a little larger as they approach the base. It will increase the sense of depth in the game and give it a little bit more visual interest. So let's do that. We're going to go to the incoming target section, and we're going to change this reset block so that we're going to first start with the size. We're going to set the size to, set it to just 10%, so it'll be very tiny. And then here in this forever block, so right after the move block, we'll change the size by, I was experimenting with this earlier and I found 0.16 seems to work very nicely. So let's try that. So let's see how I do. Well, in this video, our project came together pretty quickly. The core mechanics of a base defense game, we were able to slap that together in just a few minutes. And it was pretty easy to reskin all the objects from a space theme to move it into a city theme. Our next video is going to be a change of pace. We'll start with a simple maze game, and we'll work on the process of polishing it level by level with a beginning, a middle game, and a conclusion, and expanding it that way. Instead of making our simple game as complex as we can in 15 or 20 minutes, in this series we'll work on polishing a simple game with a title screen and a tutorial and a system for changing levels. In this first video we'll just focus on the artwork. Soon we'll code it up and start adding levels that have different functionalities, and we'll work on switching between those levels in an efficient way so that you end up with a polished game. I'm starting with the new Scratch project. I'll delete our default cat. The character I'm going to create needs to rotate on its center, and that means there can't be any projecting parts. So I need to work with a perfect circle. So I'll paint a new sprite. I'm going to work on the vector editor. I'll use the ellipse tool and then hold down Shift in order to drag a perfect circle. Try to center that, and we'll get some colors. Let's get a nice cheerful yellow for one color, and for the next color we'll get this kind of rusty orangish sort of color. We'll use the fill bucket, and let's flip these colors so yellow's on the inside. There we go. Okay, so now we have a nice shaded ball. I'm going to flip the color to get rust. So I'll get the paint bucket, and I'm going to touch where the border of this character would be, and I want to make it a solid orangish kind of color just on that border. Now let's make some eyes so we can tell our character is facing in this right direction. So I'm going to start by creating another ellipse, drag an ellipse like this, change the color. Let's get the paint bucket, let's give it a solid black fill, and I want to get the border white color, and I want to make that border pretty thick. So we'll select that, make sure we see these selection tools, and then now live we can change that border. So now we've got a nice thick eye. It's a little big, so I'll drag it down this way, stretch it this way. All right, so that's pretty good. And I'm going to use my duplicate tool. We'll get a duplicate of this eye. We'll drag them over here. I'm going to zoom in a little bit, and we'll just arrange him a little bit. Okay, and let's make sure that our character is centered. So I'll click the Set Costume Center, and there we go. Now, if your costume looks like this with the sprite in the corner, I confess I'm not entirely sure why Scratch does this, but there's actually an invisible detail up in the upper left-hand corner of this sprite. So I'm going to click this equal sign so we view the whole image. I'm going to use the arrow selector. I'm going to select the upper left-hand corner. And now that invisible detail is selected, I'm going to hit the delete key. If we left that detail there, it might mess up the sensing of walls and things like that. So let's give our sprite a name. We'll call him Yellow Ball, and he'll be all ready for us to make him move in the next video. Let's now create a maze backdrop for our character to be trapped in. Click on the stage, and I'm going to call this backdrop Level 1. I'm going to use the vector tools, and we're going to make all these walls the same color in order to simplify our coding of collisions. So I'm going to select this nice dark purpley kind of color. I'm going to select the rectangle tool. We'll make this line a little thicker. We'll make sure that we're drawing a unfilled rectangle. Drag it on this way. I think I actually want those lines to be a bit thicker. Okay. I'm going to drag this corner a little bit more. Okay, so now I have a nice thick border. And now using this straight line tool, I'm going to add some additional lines for additional walls for your character to move through. Now, exactly what your maze looks like is really not all that important. So I'm not trying to be precise or anything. So we have a kind of maze that'll trap our character. Now, professional games have a startup title screen. We'll paint a new backdrop. I want this title screen to come first, so I'm just going to drag it up here. We'll call it title. And I'll use the vector tools again. I'm going to create a text block. Let's use this darkish yellow color. Yellow Ball. I will adjust the size a bit. Centered. I'm going to create another text box, black this time, and we'll describe the controls and kind of state the point of the game. Okay, there we go. In this game, we're not going to use the same up, down, left, right arrow keys we've moved before. Instead, we'll kind of drive Yellow Ball like a car. Get to the, well, what do we get to? I'm going to create a filled rectangle with this cyan color, and that will be our target. So we've created the artwork for the first level and the title screen. In the next video, we'll code those things up. We're ready to start coding. First, let's make our character move. Right and left will control rotation, and the up arrow will move us forward. With the yellow ball selected, let's add the following blocks to the Scripts tab. From Events, when the flag is clicked. We'll start off by showing our character. Then we'll get our handy popular forever block, and we'll start off with an if loop. We will sense whether the right arrow has been pressed, and if so, from motion we will turn right 15 degrees. I'm going to right-click on the if-then block, duplicate this section. I'll change the right arrow to left arrow, drag this away, and we'll get turn left 15 degrees. And then I'll duplicate the if-then block again. We'll get the up arrow, and instead of that, we will move. I found 10 steps was a little fast, so we'll move forward 5 steps. So let's test it. Okay, we have a character that we can drive around on the screen. Now let's add the code to make the character bump into a wall. Let's go to the stage. We'll activate the level 1 backdrop, and then back to the yellow ball and scripts. We'll get an if-then control block. We're going to sense whether we are touching a particular color. And I'm going to click on that square, and now I click on the color I want, and now you can see that that purple color is there, part of the sensing block. And what we're going to do is we're going to have our character rebound. We're going to move -5 steps when we bump into a wall. So let's see how that works. Okay, not bad. In order to give the walls a little bit more solidity, let's add a sound effect. Let's go to the Sounds tab. We've got the default, which doesn't help us much, so let's choose a sound from the library. Effects, I like this. Let's select it, and then OK. Now, from the Scripts tab, we go to the Sound palette, and we can play the sound pop. Now we get a satisfying when we hit the wall. Instead of beginning the game by clicking a start button, we're going to have the player follow a little tutorial on the opening title screen. First, let's make sure that the player sees the title screen when the game starts. We'll go to the stage, and we will add on the events palette, when the flag is clicked, looks, we will switch backdrop to the title. Hooray, that works. Now we want to make sure that touching the cyan box triggers the next level. So we'll go back to the yellow ball on the scripts and we'll add the following inside our forever block. From control, we'll add another if then. I'm going to put it above the wall sensing, touching color. Let's make sure that we've got the color, which is the cyan block that we want. Then we will use the events and we will broadcast a message. Again, a message can be anything, and we'll give it a meaningful name, level 1 begin. Now on the stage, we will add a block. When I receive level 1 begin, we want to change the backdrop to level 1. Okay, it works. Now look at this, when I try to run it again, because the character is overlapping where the cyan block appears, we get this weird flickering effect and it does not seem to be working. So what we need to do is we need to make sure that when the level starts up, we carefully position yellow ball so he's not overlapping anything important. So for now, I'm going to drag yellow ball away from where that cyan block is. And when this game begins, I want this guy to be a little bit larger. So I'm going to click the grow icon on him. I want him to look down just a little bit more. So I'm going to, let's see, it says, all right, so his direction there, it says 145 degrees. Okay, so what I want is when the game begins, I want him to be at this XY coordinate. If you watch those numbers, when I move this guy around, those numbers change. So I don't even have to remember what those numbers are. All I have to do is drag this block here so that when the game begins, first I want to move this guy here. Under looks, the size of the character changes, and here we have set size to 185. And if you remember over here, the direction he's pointing in 145, so let's go back to motions, and we will point him in the direction 145. So now, if he's over here, we start the game there. He appears where we want him to appear. And now we move him there, and ooh, that was weird. Now, of course, he's much too big for this maze, and he was overlapping a maze wall. So first, let's stop this. I'm going to say I want this guy to appear over here, and I'm going to want him to be smaller so he fits this maze better. And I'm going to make him, let's see, I want to make him look down. So that's basically, he'll be looking down 180. That's his XY coordinate. Okay, so let's go over to events. When I receive level 1 begin, I want to move this guy to this location. I want to make him set to this size, and he's pointing in the direction, well, he's basically pointing in the direction down. So we'll just use it that way. Okay, so let's try it now. All right. Finally, let's create the cyan box that will trigger the end of level 1. This box won't do anything yet, but we'll still have it in the backdrop so that when we add code to it in the next video, it'll be ready. So we'll get the rectangle, make it a filled rectangle, put this guy here, and we'll remember to get this same cyan color and fill him with that. So in this video, we slapped together a very simple maze game, adding a pre-game tutorial that's kind of functioning as a level 0, and we can set the size, location, and direction of the player so that when a new backdrop appears, he seems to fit his new environment. In the next video, we'll create more levels, each one introducing another element to complicate the gameplay. We'll also introduce an organized system for shutting down the current level and starting up a new level. We touched on this in the Escape the Room point-and-click adventure game, but I want to do it more systematically here. A good game will get a little more complex with each level. And for this next level, we're going to raise the stakes a little bit. I'm going to create red walls of death that will kill the player on impact. So we'll click the stage, backdrops, I want to paint a new backdrop. I'm going to convert to vector. I'm going to use the pencil tool with a nice bright red color, and I'll get a thick line. And now I'm going to draw very quickly a spiral maze. Okay, maybe that's not a very challenging maze, but you get the right idea. I'm going to smooth this out. We'll click the reshape tool. I can click on my figure. Each one of these circles represents a point that I could move individually, but that's a little bit too complex of a shape. So I'm going to smooth that shape out. And now, if I really want to, I can kind of adjust these individual nodes. Okay, now I also need to create the target. So we'll make sure that we have a filled rectangle and the cyan color, and we'll add our target. I'll also remember to name this level 2. Now let's code the death walls. Go back to our yellow ball and scripts. And here in the forever block, we'll add another if-then control block. We will sense for touching color. Click inside the color box to get the selector, and I click that red. So now if we're touching the color red, what we want ultimately is to give some kind of visual feedback. So we'll say, ouch, then we'll wait 1 second, and then we will stop all the script. So that will cause the game to end when yellow ball touches red. While we're testing it out, instead of actually ending the game with the player's death, we'll settle for saying ouch for 1 second, and then we'll have the character rebound, move back 5 steps, which is the same way that we add some solidity to a regular wall. So when I click the green flag to run it, we find ourselves back at the title screen. Now that our game is getting a little bit more complex, testing out each new element takes a little bit more work. Trying to solve one problem often leads us to a different problem that you end up having to solve first before you can solve the original problem. So we can't actually test the death walls unless we're on level 2. Let's make sure that we can get to level 2 from level 1. And, well, it's really easy to get from the title to level 1. That's not a problem. But, now I have to move my guy and solve this maze. It would get really tedious if I had to solve each level in order to get to the next level just to test out a tiny adjustment. Fortunately, there's a shortcut if we go back to the beginning. One of the cool things about Scratch is all the elements are live. So as we're developing the game, I can just drag this item and put it right on top of the ball. So watch what happens when I touch this cyan square. Now what we want is for level 3 to start, but all that happens is the level starts over again. I keep doing that endlessly. Scratch is doing exactly what we told it to do. When you touch the color cyan, you broadcast level 1 begin, and that starts the level. Instead of having this collision specify level 1 by name, we're going to generalize this broadcast so that we can reuse it. We will create a new message. We'll call this level up. We'll just make sure that every other object in the game knows to listen for that level up broadcast and then hides or shows themselves at the proper time. Stay with me, this is easier than it sounds, it just requires a little bit of setup. So here in the Scripts tab of Yellow Ball, let's change this when I receive, instead of level 1 begin, let's instead respond to the level up broadcast. And this level up message is going to be sent every time a level ends. So we need to add an if-then statement, and we're going to check to see whether the backdrop name equals title. And if so, we'll move, scale, and orient Yellow Ball the way we want him, and we will also switch the backdrop to level 1. Let's see if that works. Okay, so far so good. Now, I think that level change was a bit abrupt. I want to add a sound effect that will kind of celebrate the end of the level and make the player take notice that something important has just happened. So, with the yellow ball selected, we'll go to the Sounds tab. I'm going to choose a sound from the library. The sound I want is from Percussion Cymbal Crash. I'll select that. Okay. Now I go back to the Scripts tab, and from the Sounds palette, now I can play Sound Cymbal Crash. I'm going to take this play Sound Cymbal Crash until done, and I'll put that here right before the level up. And what that will do is it'll cause the game to freeze just for a little bit, just long enough for the player to register that something important has happened. Now I want to add just one more sound. I want to start every level with a pop noise. So we'll get something like this. To end level 1 and start up level 2, we'll continue the same process that we developed when we switched from the title to level 1. We need to tell Scratch where Yellow Ball should begin level 2. So I'm going to stop this game, I'll go to the stage, go to the backdrops, and I'll kind of artificially set up this level 2. And, well, as it happens, that's a perfectly good location for Yellow Ball. I'm going to do something. I don't like this orientation. I'm going to flip this, move this around like this. We'll get a different shape there. Okay, that's a little bit better. So now I'm going to have Yellow Ball start down here, back to the stage, click the Reshape tool, open this up a little bit. Okay, that's fine. So now we'll go back to Yellow Ball and Script, and we'll see what orientation we want him to be. Let's move this guy. Okay, that looks good. So now what we need to do is add another if-then block. If, and we'll get the equals block. And from looks, we get backdrop name. If the backdrop name is level 1, then we will, from motion, we'll pick this XY coordinate. He's facing left, so we'll point in the direction left. Then from looks, we will set size to 115, and we will switch the backdrop to level 2. So let's see how that works. Okay, did you notice what happened? What we want is level 1. It jumps ahead to level 2. Okay, well, obviously the computer hates me, doesn't like me, it's mean, etc., etc. Okay, no, that's not what the problem is. The problem is simply Scratch is faithfully doing exactly what we told it to do. We just told it the wrong thing. Let's walk through this stack and you'll see what's happened. When the level up message is triggered from this screen, because the yellow ball has touched this color, then Scratch checks to see, is the backdrop named title? And it is. So it moves the yellow ball to these locations and changes the backdrop to level 1, and then it finishes this block and goes right into this next block. This block asks, does the backdrop name equal level 1? Well, in our case it does, because we just switched it to level 1. So the switch is actually pretty easy. All we have to do is take this block and insert it up here. So we'll just have to make sure that we always remember to check for the backdrop name in reverse order. As we add new levels, we have to add them in at the top of this list rather than at the bottom, and that will avoid the problem. So let's check that again. We're running this again, and we see level 1 as we expect, and then now we see level 2 as we expect. Finally, we get to check our death walls, although, they're really just kind of ouch walls. If I had time, I would actually check to make sure that you can drive yellow ball through this maze and get all the way to that target. Just to save time, I'm not going to do that. I can just drag it. Nothing's going to happen now, because we haven't yet coded what happens if the backdrop name is level 2. We'll do that in the next video. Now, this stack of blocks that's sitting off right here, this is the stack of blocks that will kill the player and end the game. I'm just going to take the ouch blocks, this is our testing area. I'm going to add this back in here. So now these walls are hot and fatal, and that ended the game. So in this video, we've added a new threat. We've set up a system that will make it very easy to add in new levels. In the next video, you'll see why it was worth it to go through this trouble of creating this general level up broadcast. We'll add a new level with a moving threat, and I think you'll be surprised at how quickly we can start adding some more complexity to our game. In this video, we'll see how to add a moving threat, which will be a new sprite that we'll have to remember to make appear and disappear on the appropriate levels. That will actually be pretty easy, since we've already set up a good expandable structure to manage our levels. So let's get a new backdrop. To save time, I'm going to duplicate level 1. And Scratch is smart enough that it's now called this level 3, which is cool. I'm going to select these wall items. And now I'm going to hit this flip button. And There we go. I've just flipped it a couple times, moving it around. Feel free to put more effort into your level designs than I'm putting into mine. If I were creating this game for real, I'd of course put the yellow ball character farther away from the target, but since we're practicing now, I'll keep them close, smaller a little bit, and we'll go to the Scripts tab, and now we need to add another version of this level switching code. So we're going to have the if-then block. We'll have the operator equals sign. From looks, we get backdrop name. We're checking to see whether the backdrop name is level 2. And if so, then from motions, we will move our character to that XY coordinate. And we will point in the direction, we'll make them point right. Then we will, from looks, set the size to what it is now, which is current, and then we switch the backdrop to level 3. Okay, so now we have another level. Let's now code our moving threat. I've already told Scratch it's failed to touch the color red, so let's paint a new sprite. Get a nice bright red color, and just make some squiggly lines. I don't know, for a little character, we'll get a thinner things like that. Okay, so now we have death squiggle. When level 3 starts, I want this squiggle to start moving around. So we'll go to Scripts, Events. When backdrop switches to level 3, we will start a forever block. We'll cause our character to move 3 steps, if on edge bounce, and then we'll move a little bit randomly. We'll get the pick random operator, and we'll pick a random number of degrees from 5 degrees minus 5 degrees. When we run this, oops, our death squiggle appears on the opening screen. That's pretty simple to fix. We'll just make sure that we add a when flag clicked. We should hide, and we should make sure that we remember to show our death squiggle at this proper moment. Now, one more thing we need to add is whenever we receive the level up message, we're going to carefully remove this character from view. So let's see how that works. Okay. Okay, so those multiple symbol crashes simply tell us that the level ended, but we haven't yet coded what happens when level up is received and the backdrop name is level 3. Well, let's do that. Let's create a level 4, and then let's create 2 moving death squiggles on level 4. I'll go to the stage, backdrops, duplicate level 3. Scratch very kindly names it level 4 for us. As before, I will hold down the Shift key in order to select more of these objects. Feel free to put a little bit more, care and effort into your own level designs. I am just trying to get some points across. All right, so again, if I were really making this, I'd probably put this guy way far away, but we will go a little bit easier on you. Point him in this direction, and go back to Scripts. Again, add another then block. I can actually right-click on this, duplicate that, drop it in there, and change that. So that's a little faster. From motion, what is this? That is minus 55 degrees. Size is 90. To switch the backdrop, level 4. Okay, that works nicely. Now let's code the extra behavior of the death squiggle. If we want 2 death squiggles to operate, Your first impulse might be just to duplicate this sprite, but remember how we created multiple bricks in the Breakout game earlier? We used cloning so that we keep all the scripts in one particular sprite, and then we clone a copy of that sprite. And that way, if we want to make changes to the behavior of our death squiggle, we only have to make changes in one place, rather than in every copy of the death squiggle that we might create. So with death squiggle selected, we'll go to Events, and when backdrop switches to level 4, what we're going to do is we're going to create a clone, create 2 clones, and then when I start as a clone, we'll get a copy of this stack. And then when I receive level up, meaning that a level is finished, that means we need to, rather than hide it, we're actually going to delete this clone. Let's see how that goes. And now there are actually 2 copies of that death squiggle running around. And when I hit the cyan block, they'll both disappear. And we sort of endlessly have this cycle because, again, we haven't told the computer what to do when the cyan color is contacted and the backdrop name is level 4. So far, this is looking pretty good, but I do want to point out a few little problems that we've created. And one is the important computer science concept of don't repeat yourself. We have 2 different places where the behavior of the death squiggle is defined. If we ever wanted to change the behavior, we'd have to remember to change it in 2 places. So instead of this block, instead of doing any of that, I'm going to throw all that away. I'm just going to, when the backdrop switches to level 3, we're going to create 1 clone. When the backdrop switches to level 4, we'll create 2 clones. We don't need to hide the clone anymore. We'll delete that, and that'll work. So basically what this means is the original death squiggle will always be hidden. On level 3, 1 clone is created, and that clone is shown and given this behavior. On level 4, 2 clones are shown, and each of those clones has that same behavior. So we've practiced some basic concepts of computer science, demonstrating the value of structuring a program, as we have a general procedure for closing down a level and destroying level-specific items. In this case, these death squiggles are programmed to self-destruct whenever they receive the level up message. We also saw how easy it was to add another level. It was also very easy to reuse the color red from the walls of death in the death squiggle. Based on what you've learned elsewhere in this series, you could probably add new levels with green mushrooms that restore your health, or golden treasure that increases your points, or who knows what. In our next video, we'll polish our game just a little bit more, and then we'll be ready to publish it and present it to the Scratch community. We're in the home stretch. Let's create 2 different endings for our game, losing and winning, and let's code them up. Then we'll publish our game to the Scratch community and beyond. I'm going to start by creating some very simple you lose and you win screens. So we'll go to the stage, backdrops. I'm going to paint a new backdrop. With red, I will draw a very simple message. Let's get a thicker line width. And I'll name this you lose. I'll paint another one in green. You win. With the yellow ball selected, the Scripts tab, we'll adjust this part of the script to trigger the losing screen. We will switch backdrop to you lose, and then we'll trigger the win by getting another control if-then block, equals operator, the backdrop name equals 4, to switch the backdrop to you win. Okay, and for the you win condition, let's make our guy bigger. Okay, so that means he is at this XY coordinate. He's pointing in the direction 137 degrees. And from looks, we'll get his size, which is 225. And then here, for now, that's the end of our game, so we'll stop it right there at level 4. Hooray! Now, if I had time, I would add power-ups that let you fire missiles at incoming threats, and I'd add threats that, shoot at you, or every time you bump into the wall, the threats turn to face you, or something like that. You can mix and match what you've learned in other videos, or go online and find out what other people have done with their Scratch projects. Well, now we have a Scratch project that works. Let's share it. Let's click this Share button. Now let's type some instructions and credits. I also added a few tags down here. So let's go brag a bit online. We'll click Embed, and then down here we have these new Share options. I'll click the Facebook icon. I'm already connected to my Facebook account. You may need to log in, but I'll say, I made a cheerful maze game with Scratch. Well, it's cheerful unless you touch something red, in which case you die. I'll share that. And there we go. Now, we'll go back. Click Embedded again. Well, let's try Twitter. There it is on Twitter. I can also embed code on a website. Before I embed it on my website, though, I'm going to come up with a better title. So I've called this Yellow Ball Maze Game. And now I'm going to share that by embedding this code on my weblog. Now, if you're using a WordPress blog, you'll need to know you'll need a plugin called Unfiltered MU in order to let this embedded code work. As you can see, here I am on my blog playing this game. Oh, he's too big to fit through there. Well, I'll have to fix that later. Well, I don't know about you, but after all that, I am pretty exhausted. So here on the Scratch website, I have created a studio called Building Games with Scratch 2.0. Let me add our Yellow Ball Maze game to that studio. There we go. The Scratch community is a great place to connect with other Scratchers, and of course you can share links to your own published Scratch projects via any social network that you want. In this series, we've made some cool games, and we've explored some of the powerful new additions to Scratch 2.0, notably the new video camera input and the vector tool set and object cloning. It's really hard to believe that all that is free. So thank you, MIT, for creating Scratch and for giving it away. If you want to see still more, we have a series of bonus videos that explore how to use Scratch's vector animation tools to create high-quality animations. You'll find those videos on my YouTube channel, www.youtube.com/dgjers. I'd like to thank Pact Publishing for giving me the chance to share this adventure with you. I hope you had fun making games with Scratch 2.0, and I hope you picked up some computer science principles along the way.